On the bench today, I have a Gardner d9400 monitor chassis. This is from my 2008 Golden Tee Live with a 27-inch picture tube. I bought the game, dragged it 3 hours home, and everything was fine. It was completely working. And then the next day, my boss called me and told me that it wasn't turning on. There was nothing on the screen. So what's happening is the game is playing blind. Basically, everything works, it's just not showing a picture. The output from the computer is fine, but as you can see from the video that I should have posted right before this, what's happening is this light is flashing, and then this relay tries to kick on, but it never really quite gets going. And the interesting thing about this is it's an intermittent problem. You see what normally happens when it works is this light will blink a little bit, that relay will click a few times, and then finally it'll kick on, and then everything's fine. And the crazy part is the picture is perfect, no problems whatsoever. But as I said, it's intermittent. Sometimes it'll kick on and sometimes it doesn't. There's not really much of a rhyme or reason to it. So there's definitely some issues with this board. Now, what makes this situation wonderful is that I've scoured the internet trying to find any information I can on this chassis. And I have learned exactly one thing about it, and that is that it exists. That's it. If you don't understand what I mean by that, basically what I'm saying is there's hardly any information on this monitor chassis at all other than the fact that it does exist. I tried calling Gardner, they were absolutely no help at all. And when I say they were absolutely no help, what I mean is I called several departments over the course of several weeks and nobody would answer the phone, which is wonderful. Any research I've done on the internet trying to find people who've had issues with them, all the forums that I've found, they all just dead end. Nobody ever reports what was the problem with them, and none of them have had the same problem. So basically, I'm completely on my own here. No idea where to start. Gardner does have a little bit of documentation as far as like wiring diagrams and like theories of operation and stuff like that, but they're very poor quality. They're nearly useless. So, like I said, I'm on my own. I'm not a monitor repair expert, but I have worked on a few monitors and nobody else has posted any videos about this monitor chassis. So I figured I would do it, show you my experience with this monitor chassis trying to get it to work again. So without anything to really give me a good idea of where I should start troubleshooting or even how to troubleshoot this particular chassis, I decided to look at one of the most common failure points for arcade monitor chassis, which is the capacitors. Capacitors are a very common failure for arcade monitors, and they also cause a whole lot of very different, very weird issues when they fail. So I looked around this board just looking for any capacitors that looked out of the ordinary, and I did find two. One was here and one was there. Now I do have the one that used to be over there. It's right here. I'm going to put this in macro so you can see it. So this capacitor, I don't know if you can tell, but the top is just very slightly bulging, not blown out, but it's the start of a failing capacitor. And then on the top you see that that tannish buildup. That's actually electrolyte that started to leak out. So just by looking at it, I knew this capacitor was bad. And then the capacitor that was here, I unfortunately don't have it so that I can show you, but it actually had corrosion around the top of it, and then the case was really rough and bulgy looking, so I could tell that there was corrosion under the case. So both those capacitors, just by looking at their physical condition, I could tell they were obviously bad. So I stuck this one in. It's the same rating, it's just a little bit bigger. This one is actually a brand new capacitor from another cap kit I had for another monitor that was left over. And then that one, for some reason I had the bright idea to put in a used capacitor just to see if it would work. Spoiler, it didn't. It didn't really make any difference. So at that point I started testing the other capacitors. So this is my Esr meter. This tests the equivalent series resistance of capacitors. When an electrolytic capacitor fails, what happens is the equivalent series resistance will kind of go through the roof usually if it's really bad, or at least it'll get too high and for a given voltage and microfarad rating, the ESR shouldn't be over a certain value. So you basically test the ESR, and then if it's over a certain amount, you know it's bad. And the great thing about an ESR meter is it'll test the capacitors in circuit. I don't have to unsolder any of these, which is great. So I started testing them, and I did find some questionable capacitors. I believe these two were a bit questionable, as well as a few others. So I decided that I'm just going to kind of shotgun a whole capacitor kit in it. We have a new capacitor kit in here. This should have all the capacitors we need. I'll list in the description the parts, which is what I always do now. Normally I don't like to just throw a bunch of parts at stuff, but in this case, you know, I don't know how old the monitor is exactly, because although it is a Golden Tee 2008, the monitor is not original to the cabinet, and the cabinet's a 2010. So I have no idea how old this thing is. Since I found a couple questionable capacitors, it's a good chance that a bunch of others are questionable as well. So we're just going to replace all of them in one go. Hopefully this will fix the problem. If it doesn't, then we're going to have to start diagnosing other stuff. Well, this took a lot longer than I wanted it to, but I finally got all the new capacitors soldered in. Over here, I have my big pile of used capacitors that all came out of it. Now, something I will say, this particular capacitor kit came with a bunch of different brands of capacitors, which normally isn't a big deal as long as they're good quality capacitors. The problem is that this particular kit came with varying levels of capacitors. There were some good ones. There was quite a few Nichicons in there, which is good. But there was also plenty of off-brand and not so great capacitors. For example, these capacitors right here, these are Hongfa capacitors, which I can tell you just by the name, those aren't going to be very good capacitors. And you know, it's like over here, this one's a Nichicon, this one's an Illinois capacitor. There's just a bunch of different brands. Normally I would suggest going ahead and buying a good quality capacitor kit, something that has high quality capacitors, you know, Nichicon, Panasonic, Sanyo, something like that. And you want them in a 105 degrees Celsius rating, because that'll make them last a lot longer and they'll hold up a lot better. The reason I ended up buying this kit is because, number one, I didn't know it was going to come with all these different brands of capacitors, and number two, it was actually the only kit I could find for this particular chassis. Now you could go through and write down all the values for all the capacitors and find equivalent replacements for them. The reason I didn't do that is simply time. If you look at this list, look how long that list is. It would take ages for me. I'd probably spend an entire day just looking up replacement capacitors if I did it that way. So I just went ahead and ordered the kit, the only one I could find. And you know, these capacitors, the lesser brands, you know, they'll work. They're going to be better than blown or worn out capacitors. It's just a matter of how long they'll last. So they might not last as long, but you know, at this rate, if I get it working and they have issues in 5 years or whatever, then I'll just go ahead and replace the capacitors that aren't Nichicon with something better. But for now, I think this will be just fine. So it's too late to go over there now, but hopefully tomorrow we'll be able to take this over, put it in the game, and cross our fingers that this solves the problem. Aha, it works. No more clicking. Yeah, looks like we're back to the flashing light again. But no clicking relay this time, so that's wonderful. Well, as you can tell by the last clip, the capacitor kit did not fix the problem. So I brought the game here to my house because it's going to be easier to work on it here than it would be there, since we're going to have to do some more advanced troubleshooting here. So this whole disaster I've got going on with the cooler is basically just to get the chassis down a little lower to a point where I can test stuff on it, see it, and work on it easier while it's still connected to the tube. We don't want to run this thing when it's not connected to the tube, but I do need to get access to it, and normally it mounts up there, and I can hardly even see the thing, much less test stuff on it. The various jumper wires are just to extend the grounds, which were the only wires that weren't quite long enough to reach down here. And as you can see, light is still flashing. It is currently plugged in right now. I just have it plugged straight into the wall without the rest of the game, so we don't have to listen to it. Something that has changed with the capacitor kit is that this relay no longer clicks on and off. It used to click about every other flash of the power light. Now I do have the schematic for this, and I looked it up, and this relay is just for the DGOS, which turns on at startup. It's not a critical feature, but what that does tell us is that for some reason that relay was being commanded on over and over again, which tells me that the monitor was getting into its startup cycle and then immediately failing. So now we really have to get down to some proper real troubleshooting here, figuring out what the heck's going on with this thing. Now the symptoms alone can start to point us in the right direction. The Wells Gardners are known for high voltage issues. The HOTS, the horizontal output transistor, that tends to fail a lot, and then they can have a cascading effect where they take out other components with them. Flybacks can fail, of course. So those are pretty common, and those will set it into high voltage shutdown. I don't think that that's what's happening because as I mentioned before, it's an intermittent problem. Basically, it will either turn on and it'll work perfectly fine, and it'll continue to work fine until you turn it off again, or it just won't turn on at all. Now, if it was a high voltage issue, like say a shorted horizontal output transistor, it wouldn't start up, period. It'd always be in shutdown mode. And even if it was an intermittent fault, it would probably fail with heat once the monitor had been running a while. And that doesn't happen either. It starts up, and if it does start, it runs perfectly fine for however long you leave it plugged in. It's when you turn it off and then try to turn it back on again that you tend to encounter issues. So I don't think it's anything to do with the high voltage sections. So that leaves either control sections or the power supply itself. Now I think it's the power supply itself. And the reason I say that is because according to the schematic, it doesn't appear that the logic portion of the board doesn't seem to have any control over the power supply portion. Now this is a switch mode power supply. A lot of these newer chassis use this. It's what allows you to run the chassis without an isolation transformer, which is really nice. Basically this entire side of the board is the switch mode power supply section, and I really do think that that's what's causing the problem, because like I said, when it switches on, it works fine until you switch it back off. So I think a component has failed intermittently, which is causing it to not start up properly. And so basically it tries to start up but fails, and that's why you end up with the flashing light. Now if we come down here, I got some schematics on the computer. Hopefully you'll be able to read this. This is the secondary side of the switch mode power supply. So this is T501, so that's the yellow transformer you saw, and then these are going to be all the output voltages. Now if you look down here, we have an LED 501. That's actually that power LED that keeps flashing, and you notice it gets its power right off this rail right here, which is 6.8 volts. Now this is labeled VCC. So I'm presuming that this is actually the voltage that all the logic circuits use in the chassis. And then if you look up here, you have all your various other voltages. At the very top here, you have your 195 212 volt. That's your high voltage. Unfortunately, Wells Gardner decided to be kind of jerks with this, and they didn't give you any test points at all or tell you where to test stuff. to get voltages from, but luckily with this schematic we can figure out where to get voltages from. So if I want to test like the high voltage, I can go at this end of D513. If I want to test VCC, which is the power going to the LED, I can just simply test it at the far end of D516. And then, yeah, I'm not going to even try to scroll this. I don't have my mouse with me. But basically what I'm going to do is I'm going to check the VCC voltage, which is what's powering the LED. And then just for the heck of it, I'm just going to go ahead and check the high voltage. If those are pulsating, then we can pretty much determine that it's a fault somewhere within the SMPS power supply. I'm going to show you how to do that. I'm testing the voltage on the VCC rail, the 6.8 rail, which feeds that LED. Got the negative on the chassis ground, and then the positive. Let me get this light for you. The positive is on the far end of that diode there. That's D516, which will give us the voltage of the VCC rail, like I said, is feeding that LED. So here's what we're getting on the meter reading. We're getting 1 to 2 volts when it pulses, if that. Granted, this is a cheap meter, so the response time probably isn't that great, but we should be seeing 6.8 volts on this rail, and we're not anywhere near that. So yeah, if any, here's the thing. If the control, if the logic portion of the board had any control over the SMPS portion, it would need to have a consistent power rail, a standby power rail. And with this being the lowest power rail, this would be that rail. So even if the logic board was supposed to switch on the SMPS, this rail should be reading full voltage all the time. So the fact that it's bouncing tells us there's definitely a problem with the actual SMPS. Now, well, we will go ahead and check the high voltage rail just to see what it's at. So D513, if I look back here, it is going to be wonderful. It's going to be at the bottom of that diode that's on that heatsink. So yeah, I can't really get in there, so I changed my mind. We aren't going to check that. Sorry to get your hopes up. Yeah, but we don't really need to test that. There are some other voltages we can test. Let me see, what is... So D515 is another point we can test at. That will give us, if we come down to the schematics, D515 is here. That will give us the 15 volt rail. So let's very carefully test that. And by the way, to test this stuff, having a set of DVOM leads that have alligator clips is wonderful. So here's what we get for that. See, I did see it reach 10 a minute ago. There it goes. So we're getting a maximum of about 10 volts on a 15 volt rail. So there's definitely something wrong with this power supply. Now I'm thinking, this power supply, it's definitely not the simplest SMPS in the world. It has an opto isolator, and it's got a feedback loop. Plus it's got a PWM driver around here somewhere, which I have now lost. So next course of action is we're going to take this out, start testing the various components of the SMPS, see if we can find anything obviously wrong. Well, the chassis is back on the dirty workbench again, got the frame all apart, and like I said, we're basically looking for a fault in the SMPS, so that's pretty much from here over on the board is the SMPS. Now, like I said, this is a little bit more sophisticated one. It's got feedback and protection, and it's also got a PWM generation circuit. So it's not the simplest SMPS in the world. So here's the schematic again. And down here, this is the feedback and protection circuit. There's the opto isolator there. And then up here is the IC that drives everything. Now, based on the way this thing is acting, I really don't think any of the main big components are having issues like the FET or the rectifiers or the capacitors or anything. I think those are all fine because, you know, if it starts up properly, it'll work perfectly fine for as long as it's plugged in. So I'm thinking it's something either in the feedback and protection circuit or something in the startup circuit most likely is causing this, because it seems like if the one component, which it's probably one component that's causing this, if that one component works properly just once, everything's fine and it works perfectly until it needs that one component again. So I'm thinking it's something that's not needed constantly, which points primarily towards the startup circuit, but I'm not ruling out the feedback and protection circuit or even the PWM circuit. The plan of action at this point is just kind of go through and just start testing everything, starting with the sections that I think are probably the problem, and then moving on if I don't find any issues there. So yeah, we're gonna get on that. Okay, so I went through and I checked pretty much all the resistors and all the diodes, as well as a number of joints in the SMPS, and I didn't find anything wrong. Reflowed a few joints, just thought I'd throw it back on here just to see what it does. And the light blinked for a little while, and then it kicked on, and now it's working again. So that's a little odd. I'm going to see if it'll start back up again once I turn it off. So it's off now. And there's static from the motor as it discharges. So let's try this again. And it's back to flashing, but it took a little while before. And there it goes again. Huh. This is odd. So something I did has had an effect. Question is what? Well, I was wrong. Back to the flashing light again. Nothing's happening anymore. So that's what I was talking about before when I mentioned that it was intermittent, but it seemed to work better after it had been sitting for a while. So it's almost like something's discharging, and when it's discharged, well, I've done a lot of reading, a lot of testing, and a lot of head scratching trying to figure out what's going on with this thing. And I have figured out a few things. First things first though, I did end up removing one component. Here it is right here. I don't remember what the official name for this is. It's printed STR83145. What this is basically just an automatic voltage switch, or it's a device used for automatic voltage switching. All this does is it allows the board to automatically switch between two 30 volts or one 10 volts for the incoming AC voltage. I was told by someone on the internet that these are not the most reliable things in the world and could potentially be causing the problem, so I decided to just go ahead and remove it and put a little jumper in there between where pin, I believe it was pin 2 and 3, and that basically locks it into 120 volts full time, which is fine because I'm in North America and I'm never going to run this thing on 220 or 230, however you want to say it. So I did more testing within the actual SMPS itself, and I'm getting to the point where I'm starting to think that it's actually not in the SMPS. I know I said I thought it was, but strangely enough, even though the symptoms present as it being an SMPS problem, it seems that might not be the problem. Now, just to see if I could get it to switch on, I decided to try loading down the individual rails, and I've been doing that with light bulbs. So I tried like a 555 bulb and then a 194 bulb on the 6.8 volt rail. I tried one of these. I think this is a 3157 bulb on the 15 volt rail. All those really managed to do was to make the light bulb flash, but I actually did find one that works. So down here I have a 75 watt black light bulb, If you're wondering why it's a 75 watt black light bulb, it's because it's the only incandescent bulb I could find in this house for some reason. Even I'm not sure why that is. But that's what I got, so that's what I'm using. And what I'm going to do with this is I'm going to use it to load down the 120 volt rail, and that will kick the monitor on. And I've done this a whole bunch of times and it does it reliably. So we're going to do this carefully without electrocuting myself, and it's going to kick on. And there it goes. And that light bulb will continue to run, but it gets hot, and because it's a black light. Also, once it is running, that light bulb's no longer necessary. It'll just keep going. So that does lead us to some other things that we can start checking. The same person who mentioned that little chip could be unreliable is also the same person who mentioned that the 120 volt probably feeds the CRT driver, which I'm presuming he means the circuitry up here, which I did check, and turns out he was right. It does feed that. Basically the 120 volt rail looks like goes straight to this connector that's PW820, if memory's, no, I'm sorry, it's PW802, and that cable brings it right up to the neck board. And you can see there's a bunch of neck board resistors and stuff on the neck board that are going to get hot. So what I think I'm going to do now is I'm going to check most of the components that I can that are on the neck board and see what's going on with those, because what it might be is that there's not enough load on the SMPS to get it to kick on, because most SMPSs need a load to be able to function properly. Finally getting to a conclusion here. Not the conclusion I necessarily wanted, but it's a conclusion nonetheless. So I checked all the 120 volt circuitry and I couldn't find any issues with it. So it's not an issue with the 120 volt rail not having enough load on it. It's just for some reason loading it down will convince it to start. So after that, I was pretty much out of ideas. So just on a whim, I decided to go ahead and replace IC502 and IC503. Don't know if I'm going to be able to get this in the video. Trying to look through the camera screen. So IC502 is right there. It's the little white thing, and there right above it is IC503. IC502 is the opto isolator, and IC503 is a TL431 shunt, current shunt. Those are part of the feedback system for the SMPS. I just grabbed some old components out of a broken power supply and stuck them in there just to see if it would change anything. And it actually did. It still flashes a lot at startup, and the rails voltage fluctuates, but the difference is that now it will actually start reliably. So it does flash at first, so there is still some issue going on, but it starts reliably now. So I don't plan on this chassis lasting for the next 20 years. It's a Wells Gardner. The chances of that happening is slim to none anyway. So all I'm really concerned with at this point is that it works for a while. So I'm good with it the way it is. Basically my plan is to just run it until it breaks again and then try to fix it then. Maybe I'll be able to find the problem at that point. If not, there's other options to get it working. But we'll go ahead, we'll plug it in and show you what it's doing now. So get that light in view. And that's the computer starting up, you hear in the background. It always takes a little longer when it's been sitting, and this has been sitting for a few days. So let's give it a moment. And there it goes. So it's all working now. We'll take a look at what's on the screen. We're getting some interference to the speakers on startup, but the screen's working. Everything seems to be functional. It's just, you know, there's still some little issue with the SMPS that's causing it to not start up right away, but like I said, at this point I'm stumped, other people are stumped. Nobody really knows what's going on with this thing. So it works. I'm happy with it for now. So that's where we're going to end it. Not exactly how I wanted this to end, but you know, it works. It's something. So hopefully maybe this will help somebody out.